Okay, let's look at example 3.8. The diameter of a metal shaft used in a disk drive unit is normally distributed with mean 0.2508 inch and standard deviation 0.0005 inch. The specifications on the shaft have been established as 0.2500 plus minus 0.0015 inch. What fraction of the shafts produced conform to specifications? Okay, let's try to understand the question by drawing again. Now, what do we have as values? Let's write them. Okay, example 3.8. Let's draw the normal property diagram. So our production, which is mu, is equal to 0.2508 and our standard deviation is 0.0005. The specifications, which means the customer, specifications means what the customer wants from the company. Customer demand, let's say, is specifications. What is it? It is 0.25 plus minus 0.0015. So let's draw this. What do they want? What are the specifications? The upper limit, upper specification will be 0.2500 plus 0.0015, that is 0.2515. The lower specification is 0.2500 minus 0.0015, which is 0.2485. So these are the values, and we will look at the area between these values. So our production is, as we said here, 0.2508, and the upper limit is what the customer wants, 0.2515, and the lower one is 0.2485. So we would like to calculate the area under this curve. For this, we need to find two z values and then try to find the area between the specification limits. What was our formula to find z? So let's say that upper specifications, z upper would be 0.2515, which is the x1 we can say, and this is x2, minus mu is here, 0.2508, all over, what is sigma? 0.0005. So This is found to be 1.4. This is the upper, or we can say Z1. For Z lower, or Z2, we write 2485 minus 0.2508 all over sigma is 0.0005, and this is found to be minus 4.6. So let's draw the diagram again to visualize the area under the curve. So here at the target, our Z is 0. On the right hand side, our value is 1.4. So let's draw it like this. This is Z equals 1.4, and here we have, I think somewhere over there is Z equals minus 4.6. So we would like to find the area under this curve. Now, you know, Z value less than 3.9. Here on the negative side, Z smaller than minus 3.9 is 0, because this goes to minus infinity and is going to 0. So this side is 0, which means that, as we said before, this part would be 0.5. Let's look at here. We would like to find this area. We can draw the symmetric of this graph to look at from the table. So here's 1.4. Actually, we can read this value from the table. Let's read it from the table. So here we have 1.4. The value is this, which is area under this curve. So whole of the area we would like to have. Actually, that's the answer for this part. 1.4 is 0.91924. So that's the, actually we don't have to say the 0.5. The graph, the table gives us the answer 1.4, and the area under this curve is, just to read from the table, 0.91924. The second part of the example, it says thus we would expect the process yield to be approximately 9192%. Okay. Nominal value. So it says that let's assume that we are producing at 0.25. What would be the area under the curve? So what was what were our specifications? They were 0.2515 and 0.2485. That was upper and this was lower limits. And let's say that mu is equal to 0.25. So these values will be same distance from the average. What is this area? We need to find the z value. How do we find the z value? These are the x values. So z upper or z1 would be 0.2515 minus 0.25 all over 0.0005, and which is 3. Z lower or z2 would be 0.2485 minus 0.25 all over 0.0005, and this is minus 3. So the z values for this one would be 3, and for this one it would be minus 3. We would like to know the area under this two specification limits, this part. How do we find it? There are many ways. You can choose any of them. One of them would be, since our table gives the right part, we may find the area under the curve when it is z equals 3. So this part from the table, that is probability of z is less than or equal to 3. This is just, it's just reading the table. Let's read the table from 3. It is 0.99865. So this is 0.99865. Okay, but we want to find the area under these limits. If we look at this area, if we subtract this part from here, which is also this part, then we would be finding the area under these limits. So let's find this. How do we find this? We know this area. If we subtract this area from 1, we would be finding this area. Let's write that part. This part is 1 minus 0.99865, which is here. What is it? This is 0.00135. So we know this area, If we subtract this area from here, which is just the same because it is similar, so the area here would be 0.0013. We would be finding the area under these specifications, which is probability of minus 3 less than or equal to z less than or equal to 3 would be 0.99865 minus 0.00135 equal to 0.9973. I recommend you to just memorize this probability because that's the 3 sigma limits. So maybe if you remember from the explanation of chapter 3, we were dividing this area 1 sigma limits, 2 sigma limits, and this were the 3 sigma limits, which is 0.9973.